The first thing we're going to talk about in this new module about the atomic nucleus is the very composition of the atom. This may be a review for most of you, but nevertheless it may be worth to review it so that as we move on, we start on similar level for everyone. The composition of, very simply, an atom is made out of protons, neutrons, and electrons. And notice that we will be using this notation, protons as P plus, and 0 for neutrons, E negative for electrons. And you can see each of these entries here. What is it that you need to know about protons, neutrons, and electrons? First of all, the charge. You have to know that protons have a relative positive 1 charge, and an electron has a relative positive, a negative 1 charge, why do I say a relative? Because in SI units, the unit of charge is called coulomb, and the coulomb, it's the SI unit, so this means that it's not, a proton is not plus 1, it's actually plus 1.6 10 to the negative 9, and it's important to know that the electron is the same charge but opposite, so both protons and neutrons have the same magnitude of charge. Neutron has 0 charge, so it's not attracted by positive or negative charges. It's also very important to know that protons and neutrons have almost the same mass. And the units in here is atomic mass units, and it's not exactly 1. It's because of the very definition of carbon 12 as being the source of atomic mass units. But it's also important to know that electrons are way lighter than protons and neutrons, almost a difference of 4 orders of magnitude. So the mass of protons and neutrons will be by far larger than the mass of electrons. Okay, so that pretty much sets up the whole composition of the atoms that you have to know. It's also very important to understand that the atom being this wide and the nucleus being this wide, there is a difference of magnitude of 10 to the 5. That means that the atom is mostly empty, and that's important to understand when we talk about electron clouds, that the electrons will be moving in mostly empty space. And is that a lot or not? Well, think of what the tennis ball, which is around 0.1 meters. That would be, if the nucleus were a tennis ball, the atom would be the size 10 to the 4 meters, that's 10 kilometers, that's probably the size of your county, or maybe the size of a large city. That's a large difference of space, so again, take-home message is that the atom is mostly empty. So what other things do we need to know about the atom? We will refer to the atoms based on its composition, and we will be using the mass number and the atomic number. Let's give you some examples. For example, when we write this, it means that it's carbon 12. That means that there's the number of protons and the number of neutrons is equal to 12. So this plus this, and the number of protons, and that's what gives you the atomic number, is equal to 6. Notice that these two symbols are redundant. To say that it has 6 protons is the same as saying that it is carbon. Okay, so most of the times we will refer to atoms as this. We will not write the atomic number down here because the element here already reveals the number of protons. So what's an isotope? An isotope is the relationship between elements in which they may have different number of neutrons, but they have the same number of protons. And from the chemical perspective, they will be identical. Okay, only they are more massive. Some of them more massive, others lighter, but they will behave chemically the same way, almost the same way. So let's run a simple example. Oh, by the way, I just wrote on it, but probably you can still read it. What is the difference? What is a cation? What is an anion? An ion will be an element in which the number of electrons is different than the number of protons. That means that there is a charge imbalance, so the ion is a charged atom. If there is more negative charge than positive charge, we will call this an anion. And if there is more positive charge than a negative charge, that will be a cation. Let's run an example and hopefully this will all make sense. In this case, for example, is asking to rank the following isotopes. These are 3 different isotopes, different elements, and the first thing that you want to do before you start decreasing it by number of protons, electrons, or neutrons is to figure out the composition. So when we write 18O2 plus, because it's oxygen, it means that the number of protons of oxygen is always the same. This is what makes it oxygen. It's 8. You go to the periodic table, oxygen is the 8th element. If this number is 18, it means that the number of neutrons is 10. And if there is a 2 plus, it means that there is 2 more positive charges than negative charges. So there has to be 2 less negative charges than 8, so there has to be 6. As for carbon, in this case, carbon, what makes carbon carbon is to have 6 protons. In this case, if this number is 13, let me remind you that this number up here, we call this mass number, this number down here, that we most of the times will avoid, we call atomic number. If the mass number is 13, it means that there has to be 7 neutrons, so that when you add protons and neutrons you get 13. How many electrons? Well, you have 2 more charges than positive charges. That means if there are 6 positive charges, you have to have 8 negative charges. And finally, for nitrogen, nitrogen 15, negative. What makes nitrogen nitrogen is the number of protons, which is in this case 7. And if the mass number is 15, there has to be 8 neutrons. Okay. And if there is 1 negative charge, it means there is 1 extra electron other than protons. They have to be 8. Okay. So if we decrease all these isotopes in decreasing, if we rank these isotopes in decreasing number of protons, the one with the largest number of protons is going to be oxygen. So oxygen 18 will have the largest number of protons, followed by nitrogen 15, followed by carbon 13. In decreasing number of electrons, you can see it here. Notice that nitrogen 15 will have the same number of electrons and then this carbon 12 to negative, and this will have less number of electrons of this 2 positive, oxygen 2 plus. And finally, number of neutrons. The largest number of neutrons is oxygen, followed by nitrogen, and finally carbon. Hopefully this will make some sense.